Okay, so let's start our session. Thank you for here our session. Uh, this is my hometown, so hope to enjoy Tokyo and Japan. Uh, I'm Yuki, a software engineer for CyberAgent, and Kubeflow working with AutoML and training, and Kubernetes batch-related project lead, and
Michał Woźniak, software engineer working for Google. Okay, so today's talk is working group batch update. So let's take a look what's new happening in the space. So working group batch is a working group, which is a forum to discuss enhancements to running batch workloads on Kubernetes. By batch workloads, I mean specifically HPC, AIML, continuous integration or data analytics workloads. But in general, any workload that is meant to be finite, in contrast to workloads like traditional serving workloads in Kubernetes, which are meant to run indefinitely, basically. The main goal of the working group batch is to reduce fragmentation in the ecosystems by coming up with APIs and primitives that can satisfy and fill in the gaps that over the years were filled in by a lot of fragmentation and different APIs in the ecosystems. So to the working group meetings, we have people coming from different fields with different expertise. We have people coming from SIG scheduling, SIG apps, SIG node, and SIG autoscaling. The scope of the working group batch discussions is pretty wide, as the field is very interdisciplinary, but in particular we discuss and identify challenges to run working batch workloads on Kubernetes. So in particular, we design and discuss new APIs to better serve the workloads. We also discuss APIs and primitives for workload level queuing and scheduling. And in particular, with the APIs for scheduling, we can achieve or aim to achieve better cluster utilization and workload performance. We are also discussing the support for specialized hardware and in particular work on integration with the array. The first project that the working group batch is working on is Job. This is the core Kubernetes API that was introduced very early on in the lifetime on Kubernetes, but at the very beginning, when Kubernetes was more focused on serving workloads, it was not very feature-rich. Over the last couple of releases, the working group batch introduced a lot of features to fill in gaps for running batch workloads on Kubernetes. Now the API is pretty much mature, but we are still in the last two releases graduating some of the important features. So in particular, we are graduated to beta managed by feature, which is like stepping stone for multi-queue, as it allows to delegate reconciliation of job objects to an external controller, which is multi-queue in this case. We also graduated to GA in the previous release, in the last release, success policy that allows to define custom success criteria for job, and actually Yuki was the main contributor for that feature. Then we also have back-off limit per index. This feature was also graduated to GA. It allows to keep track of pod failures independently for each index. Then we also planning to graduate to GA pod replacement policy, which allows to delay creation of the replacement pods until the previous pod is fully terminal. So this is actually quite important for AI ML workloads to ensure that if a pod fails, there are not pods running at the same time. Okay, the next project I would like to introduce you to is Kueue. This is by far the most active project that the group is working on and the biggest. So Kueue is a workload level scheduler that basically determines where to start or stop the workload as a whole. So in contrast to kube scheduler that is aware only of or schedules one pod at a time, we schedule entire workload. And what is also important for Kueue is that we actually delay creation of pods until the Kueue admits the workloads. So this significantly reduces the load on the control plane, because if you have many queued jobs, let's say 1,000 queued jobs, each would have 1,000 pods, then you don't need to create million pods in advance that couldn't run until the jobs are admitted. With Kueue, we also support all or nothing semantics. This is also quite an important feature for AI workloads, because most often, for most frameworks, the workloads cannot make progress if any of the pods is not working. So all of the pods need to be running at the same time. And finally, in large heterogeneous clusters, you can have capacity coming from different sources. So you can have reservations, you can have spot nodes, you can have capacity coming from autoscaling. So Kueue can respect preferences set by the user to put the job or the workload on the set of nodes that it finds capacity for, and it also matches the preferences of the user. So another aspect of Kueue, which is quite important, is that it's a quota management system, multi-tenant. So we can express quota constraints between multiple teams, which often are in the hierarchical organization. So we support the whole hierarchy of teams. We support also borrowing of the resources, so quite a versatile semantics of quota management, and also quota management for specific types of hardware. Another important feature of Kueue, or maybe principle of Kueue, is that we try to meet users where they are. So as I mentioned before, there is a lot of various job types in the ecosystem. We support many of them. In particular, for training, we support Kubernetes jobs, JobSet, Kubeflow, Kueue. Then for over last couple of releases, we started to support also inference workloads, such as deployment, stateful set, leader worker set. And we also support more universal workloads, such as AppWrapper, plain pods, or pod groups. As I mentioned before, Kueue is quite an active project. We have now a stable release cadence with one release every 2 months. The last release was 0.12 just 3 weeks ago, and the major focus over the last 2 releases was on the following features: Topology-Aware Scheduling, fair sharing, and hierarchical cohorts. So let me introduce Topology-Aware Scheduling in Kueue. So let's imagine you have a new shiny cluster and you are ready to start training some AI. So naturally you schedule workloads. However, if you delegate this job of scheduling to the core Kueue scheduler, the pods will get scattered all over the cluster. And for AI workloads, that's not very good, because most often there is a huge amount of data exchanged between the pods. In particular, for framework like NCCL, you have a lot of traffic between the neighboring pods. So every pod is indexed, and you have they create ring-like structure, and there is a lot of traffic. So in the picture like here, you can see where the links or the switches become bottleneck for the traffic, significantly slowing down the training as a whole. So yeah, this cannot be as performant as it could. So the picture we would like to have in Kueue is by being topology aware of the cluster, and also being aware of the workload as a whole, not in just individual pods. We can place pods so that they are compact placed in the cluster, in the topology of the cluster, and then minimizing the traffic on the links and over the switches. I will not go now into details of how we do it exactly. If you are interested, you can find more resources in our documentation or our talk that was with Yuki that was specifically devoted to Topology-Aware Scheduling, where we go into more details. But here, let me just summarize the main takeaways. So the aim is to improve performance of the AI workloads by compact placements and rank-based ordering. Also, as a side effect of the new feature, we actually improve experience of Kueue for users by eliminating the inaccuracy of scheduling due to not taking into account node capacity fragmentation. So in the past, it was possible that Kueue would admit a workload based on just quota, but not being aware of capacity fragmentation, so the pods would actually be pending. Okay, now.
Okay. Next, I am going to talk about fair sharing in Kueue, which is a fair resource distribution across multi-tenants. Okay, let's imagine the situation where we have shared ML platform between Seattle-based team and New York-based team. Now, the shared computing resource usages are still 0% because both cities are still night. After some hours, firstly, New York team started their work since it is placed at East Coast and they submit jobs. Now the cluster usage increased to 90%, for example, and the free computing resources are very small. After some hours, the Seattle team started their work. However, the cluster computing usages are already occupied by New York team. If either team are working on more higher priority products, it should be fine because the job preemption based on priority works well. The higher priority jobs are always respected. On the other hand, what if both teams are working on the same priority products? In that case, Seattle team could not never get enough resource capabilities every day because the morning always come from New York. At this point, fair sharing is helpful to mitigate this resource unfair distribution across multiple regional teams. In the case of enabled Kueue fair sharing in the cluster, if Kueue detects the resource unfairness in the cluster, when Seattle team submits new job, Kueue preempts jobs to distribute fairly resource usage, even if preemption target jobs are the same priority as well as new jobs. After enabled Kueue fair sharing, both teams are happy because they can obtain enough resources. This is Kueue fair sharing. In the next is hierarchical fair sharing. In the previous slide, I was introduced about the story for the flat organization structure case. However, we typically have hierarchical organization structure. In that case, fair sharing can mitigate the resource unfairness as well as a flat organization structure. In the next slide, let me quickly dive into the fare sharing mechanism by using a hierarchical organization structure story. Okay, now let's imagine we are AI company, and we have research and product ML division. Both divisions have two teams, and the division managers expect to fairly resource distribution across division level instead of team level. In this case, they want to have fairness between divisions. Again, once the class admins enabled fair share, Q calculates a dominant weighted share value based on borrowing, available, and admin-defined weighted value. Here, the borrowing means how much resources the division borrow from another division over nominal quarter. And the available resources indicate how much resources are available based on sum of nominal quarter, borrowing limit, and lending limit. And Q basically allocate resources to tenant with lower dominant weighted share value. So in that situation, resource division can retrieve computing resources than product ML division. Okay, in the next, I will going to talk about recently Q updates and highlights. First is 0.11. In the 0.11, we introduced native app wrapper and reader worker set integration support, and we now support pods, Kubeflow, and every jobs in multi-queue. Multi-queue is multi-cluster supporting by queue, and as I mentioned, fare sharing. Actually, fare sharing is compatible with hierarchical organization and cohorts since 0.11. And as Michał described, we have Topology-Aware Scheduling tasks. Now task supports preemption and cohorts. Cohort is cluster queue group. And tasks also support defaulting task enabling. This allows us to automatically calculate topology when data scientists submit job into cluster. And 0.12, we have object retention policy. This is automatically cleanup of finished or deactivated workloads, which allows us to reduce Kubernetes control plane high availability. And we now start to providing QBs, which is Q front-end components. And actually, so in the previous slide, I introduced preemption-based fare sharing. However, since 0.12, we started to support fare sharing with admission-based, which means historical data. And we have a couple of task improvement, something like cluster autoscaler support and node disruption detecting or something. And this is future queue planning. In the next 0.30 version, we want to introduce two-level scheduling, Topology-Aware Scheduling for JobSet and reader worker set, which allows us to scheduling each replicated job to dedicated host, zone, region, data centers. And we want to introduce a multi-queue configurable dispatching API. This allows us to select which cluster should get new work or new jobs. And this is configurable and extensible API, so class admins can implement their algorithms by themselves. And DRA integration, DRA is device management new interfaces. So currently, Kueue does not natively support DRA related fields. However, we will start supporting in the next 0.30 version. And one important thing is dynamically sized workloads. Currently, Kueue does not consider the situation where the job is automatically scale up or scale out after job started. However, in B0.30, we will go soon. Additionally, we will promote cohort API to beta. And the next project is JobSet. JobSet is a managing group of Kubernetes job as a unit. In typical AI workloads, they have reader and worker replica, and so each replica has different roles. However, the native Kubernetes API, Kubernetes Job API, does not allow to specify different pod template, pod spec in a single API, single resources. However, the JobSet support it. And additionally, JobSet support advanced startup execution or failure handling features as a unit. And actually, JobSet is used in multiple open source projects like Kubeflow Trainer and Metaflow distributing training. Yes, and this is a JobSet 2025 roadmap. The first is graduation. Currently, JobSet API is alpha stage. However, we will go promote the API to beta, but no beta, API to directly to a B1 version. And in place container restarting feature. Auto scaling replicated job and DRA supporting as well as Kueue. And finally, stateful job set. This is the same functionality as stateful set PVC template. Okay, next, Michał introducing Kueue CTL.
Okay, so let me return a little bit to Kueue and present a couple of other spin-off projects. So one of them is kueuectl and kuevis. So kueuectl is basically a CLI tool that is meant for day-to-day operations for Kueue to make them a little bit easier so that users don't need to necessarily interact with YAMLs directly. So users can create queues, stop, start them. They can list workloads, get their position in the queue, or just delete workloads. The CLI comes as a kueuectl plugin managed by Kueue. Then kuevis is the dashboard for Kueue so that admins can see in the real time the state of the cluster. In particular, they can look into the state of local queues, workloads, cluster queues, cohorts, or resource labels. So basically, all of the core APIs of Kueue are currently supported. And the last release, 0.12, was the first release actually for kuevis. So we are very happy that we finally have some dashboard. kjob is the next project in the ecosystem that was also quite recently introduced. This is a CLI tool which comes with CRDs that allow users or admins to define templates for jobs, because very often we see the thing that many jobs would repeat a lot of fields like configuration for volumes or other networking resources that are repeated for many jobs. And ML researchers don't necessarily want to look or know about the details. So admin can create the template with some of the fields that are kind of technical pre-populated, but left blank some fields which are meant for researchers, let's say the command line or maybe resources, etc. So with this tool, the flow is basically that admin creates the templates, researchers select the template, fill in the parameters. When sending the command to via kjob, kjob combines the parameters with the templates, generates the final YAML that is submitted as a job to the API server. So basically streamlining the process of submitting jobs. So this was quite a few projects in the rich ecosystems of batch. So to make sense of it and summarize, we have at the very bottom Kubernetes. That's what we are working on, what the conference is all about. Then we have Kueue that we envision as the main layer for running or getting capacity managed by Kubernetes. In particular, the GPU capacities. On top of Kueue, we envision running batch workloads like Job, JobSet, Kubeflow, but also inference workloads that can share the same pool of resources managed by Kueue. Then we have kueuectl, kuevis, which are the front ends for Kueue for the ease of use. And then we have kjob, which is another CLI tool for the ease of use for creation and management of the jobs by AI researchers. So this is like the current status of the ecosystem. Of course, we know we are not done yet and things evolve. So if you want to be part of the discussions, which way to go, where you see gaps, or you have some ideas, or you would like to contribute to some of the projects, then reach out to us. The easiest place probably to find us and where we are active is Slack, working group batch channel. You can also find us on bi-weekly meetings every Thursday. Every second Thursday, you can find more info under the link also. So thank you for attending the talk, and we are happy to take some questions.
Thank you very much for the talk. I have a small question. What's the main difference between Kueue and Armada? In a sense of, does it solve any issues which Armada has, right?
So Kueue is under CNCF. It's like Kubernetes native solution for running batch workloads. As specifically, there are a lot of similarities. So I think Armada also supports multi-queue dispatching. But with Kueue, our main vision is to make it fully like Kubernetes native. I think also Armada was originally for on-premise design, so maybe doesn't have that good support for auto-scaling. So when we design new features in Kueue, we always take into account how it would integrate with or work in auto-scaled environments. Yeah.
So it's more cloud native, right? Friendly.
Yes.
Yeah. Thank you.
What do you think the criteria are for Kueue version 1?
Yeah, good question. As you know, after we graduate to API to B1, it's challenging to break API and the specification, right? So actually, we have a lot of alpha and beta features, something like Topology-Aware Scheduling and hierarchical codes or more and more. So before we go to B1, I want to mature more and more the alpha features. is this answer for your question?
It's an answer. I ask because I know a lot of users don't like to use projects until they're V1, until they're GA. And I see a lot of features being added, and I wonder, when do you say, okay, we know, these 10 features are done. That's version 1, right? And then you can add more, but either if you don't have any users, then you can break the API. But if you have users, you can't break it anyway, right?
Yeah, so definitely we already have users, so we are committed to maintain the APIs at some point. Even there are expectations about the API at alpha level already. But that's a good question, and it's an ongoing discussion. We don't have now clearly defined expectations for moving Q to V1. Probably it is Topology-Aware Scheduling, hierarchical cohorts. Yeah, these two features are, I think, quite expected by the users. So
yeah, because those features deeply depends on our core API, workload API. So I want to avoid workload API breaking. However, actually, so we are currently planning to promote API version B1 beta 1 to B1 beta 2 in the next couple of cycle. So yeah, I'm happy to getting any feedback for next B1 beta 2 promotion or something. Yeah, thank you.
But also one more aspect maybe is that actually one of the benefits of Q that we see also got feedback from different angles that it's very good because it moves fast, much faster than Kubernetes. So for every feature to reach users in Kubernetes, you basically need 8 months for 2 cycles of the API graduation, first to alpha, then to beta. So in Q, generally we, because it's not yet V1, we take a little bit more of freedom to move faster. And for now, this we find and get feedback that it's the benefit for users at the moment. But certainly we will reach the point at which we need to switch more to maintainability. Where it happens, yeah, it's an ongoing discussion. Any other questions?
All right. Okay.
Thank
you.